Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a database design concepts, as well as the same chapter, that is chapter number 2, that is the introduction to the relational model. In the last class we have started about this chapter, or we have started about the of this chapter, that is chapter number 2, that is the introduction to the relational model. So let's start with the previous class session and then move to the next topic, that is the next part of the database, or that next part of the relational model. So let's start with the previous class session, that is what we have covered in the last class. So that is starting with the chapter number 2, that is the introduction to the relational model. So what is a relational model? It is nothing else but when we combine multiple data, that is when the data is of multiple types, and there is a collection of multiple tables and the data are interrelated with each other, that is done by the relational model. So a relational model consists of a collection of the tables, each of which is assigned a unique name. So there are multiple tables that is available in the relational database, because there is a relational database that is a collection of various tables and there is a relationship among these tables. So a relational table consists of a collection of tables, each of which is assigned a unique name. For example, consider the instructor table of figure 2.1. For example, consider the table instructor table, that is there is a table that is an instructor that stores the information about the instructor. That table contains 4 columns, that is ID, name, department name, and the salary. And each row have multiple tables, multiple data, and there is another table that is known as the that stores the information about the courses. So another table is courses, and the third table is prerequisite, that is a PRERIQ, that is a prerequisite. There are 3 tables and they are related with each other, and their relation is shown with the help of the relational model. In general, row in a table represent a relationship among a set of values, and the tables are known as a relation in the a relational database system. So therefore, in a relational model, the term relation is used to refer to a table. So whenever we talk about a relation, that is also only nothing but only a table. While the term tuple, that is tuple, is used to refer a row. So when we talk about a row, that is a tuple, and when we talk about an attribute, that means a column of a table. So relation means table, tuple means row, attribute means column. So these are the 3 fields that is used in the relational model. Then we talked about what is a domain. When the domain is known as atomic, if the elements of the domain are considered to be indivisible units. For example, suppose the table instructor has an attribute phone number which can store a set of phone numbers corresponding to the instructors. Then the domain of phone numbers, which could would not be atomic, since an element of a domain is a set of phone numbers and it has subparts, namely the individual phone numbers in the set. The important issue is not what the domain itself is, but rather how we can use the domain elements in a database. Suppose now that the phone number attribute stores a single phone number. Even then, when we split the value from the phone number attribute into a country code, an area code, and local number, we will be treating at a non-atomic value. This is just a theory that we have studied, that is how the database or how the relational model will be used to permit the storage data. Now next is database schema. That is a what is a database schema and how we are using the database schema. So a schema is nothing but the overall design of a database. That is the overall design. So when we talk about database schema, that is the overall design of a database. So database schema means what is the overall design of the database, or what the database looks like. That is the database schema. So when we talk about a database, we must differentiate between the database schema, which is the logical design of the database, and the database instance, which is a snapshot of our data in the database at a given point of time. So when we talk about a database, there is a difference between the database schema, that is only the logical design of the database, and the database instance, that is a snapshot of the data in the database. That is a what the snapshot, what is the output of the database at a given point of time. So there are 2 terms, one is the database schema, one is the database instance. And this is a diagram that is or this is a table that shows the department relation. This is also the department relation. The schema for that relation is this one. That is what is the schema, that is what is the logical design of the table, or what is the logical design for that relation, for that table. This is a logical design. There are three headings, there are three columns: department name, building, and the budget. This is another table, this is another logical design, another schema for the another table. This is another table, that is the schema of the another table. And this is also the relation table of the other relation. So schema in simple terms says or shows about the overall design of a database. That is a what is the logical design of the database, or how the database looks like. That is the logical designing of a database, right? Then next topic that we have covered is the keys. That is, there are multiple types of keys that is uniquely identify or that uniquely identify the database or the tuples. So there is a key that is known as we can say that the primary key, foreign key, that is used to logically identify the or uniquely identify the tuple. In other words, no two tuples in a relation are allowed to have exactly the same value for all the attributes. That is, no two rows in a table are allowed to have the same value for the attributes, for all the attributes. That is, there is no duplication of the records, because when there is a duplication of the records, there will be error in the database. So keys must be used. That is, a primary key must be used to differentiate between the various values, to differentiate between the various rows, tuples in the database. A superkey is a key or is a set of one or more attributes that taken collectively allows us to uniquely identify or identify uniquely a tuple in the relation. For example, the ID attribute of a relation instructor is sufficient to differentiate one instructor tuple from another. Therefore, ID is a superkey. So, what is a superkey? That contains one or more attributes that are taken to collectively, that are combined together to identifying a tuple in a relation. So, whenever I want to identify a tuple, identify a row in a relation, that will be identified by using the superkey. And there is a primary key, that is a primary key that is used to uniquely identify the row. Suppose there is the instructor table. So what is the primary key? That is the ID, because ID is not similar or not same for two or more persons, but the name is same for two or more persons. So primary key is the key, that is a column that uniquely identifies the table, for example ID. So primary key must be chosen with the care. This says the same example. The name of a person is obviously not sufficient because there are so many persons with the same name. Everything is same that we have studied about. Then schema diagram, that is what is a schema diagram, or what are the various schema diagrams that is available, or what is a logical design or logical design diagram of the database, that is a logical schema. So this is figure 2.8 that shows the schema diagram for a university. So this is a university database. This is the text, then student table, then section table, then time slot, and these are the different IDs. And these are the different, we can say, the column headings, and whatever the column heading that are underlined, that is a primary key that is available in that row, in that table. Then next is relational query languages. That is how to use a relational query languages, or what is a query language. So in simple terms, a language that is used to request, or in which a user requests the information from the database. That is, user writes a query, you request for the information, writes a query, and get the information. That is a query language. So when we talk about the query language, a language that is used in which, or that is used in which the user requests for the information through the query, that is a query language. So a language in which a user requests information from the database. There are two types of query languages. One is a procedure language, one is a non-procedure language. In procedure language, the user instructs the system to perform a sequence of operations on the database to compute the desired task. But in a non-procedure, the user describes the desired information without giving a specific procedure. In procedure, there is a specific procedure. In non-procedure, there is no specific procedure, but only a user describes the desired information. Then And next is relational operations. That is, what are the relational operations that is available in the database? What kind of relational operations that is available in the database? That is the today's topic, today's class topic. So let's start with the relational operation. That is, what are the various operations that is available in the relational model or relational table? So what are the various operations that will be performed by the relational model? So this is all procedural relational query language provides a set of operations, that is not non-procedure, but only the procedure query language provides a set of operations that can be applied to either a single relation or a pair of relations. So whenever we use a procedural query language that provides a set of operations, that provides a multiple operations that can be applied to a single database or single table or a multiple table or a group of tables. These operations have the nice and the desired property that their result is always a single relation. That is, if there are multiple tables, if there are multiple data, multiple relations, multiple scenarios, but the output is always a single relation. That is the main concern, that is the main result. This property allows us to combine several of these questions in a modular way. Specifically, since the result of a relational query is itself a relation, the relational operations can be applied to the results of the query as well as to the given set of relation. So whenever the output will become that will give only the table, that will give only the one table, that is a given set of relations. The specific relational operations are expressed differently depending on the language. So it depends on the language, that is the what is the relational operation or what are the various operations that will be performed by the relational model. The most frequent operation in the is the selection of a specific tuple from a single relation, that is a constructor that satisfy or instructor that satisfies some particular predicate, that is a salary is greater than or greater than 85,000. That is the one of the operation, that is a relational operation. But so in simple terms, relational operation means the operations that is carried out using the procedure query language, and there is a logic behind these, there is a relations behind these, there is a relational algebra behind these, that is a relational operations. The result is a new relation that is a subset of the original relation. For example, if we select tuples from the instructor specifying the predicate salary is greater than 85,000, then we get the shown in the figure 2.10. So this is the one of the operation. I applied the operation that the find the employees whose salary is greater than 85,000. So these are the four employees that is available whose salary is greater than 85,000, and on the basis of the salary and these three fields are also sorted out, that is there is ID, there is a name, there is a department name, ID, name and the department name. Another frequent operation that is used to select certain attribute, that is a column from a relation, that is multiple columns want to be selected from a relation. The result is a new relation. So what's the result after selecting multiple columns? That is a new result or the new relation or the new table having only those selected attributes. For example, suppose we want a list of instructors ID and salary without listing the name and the department name values from the instructor. Then the result is available in 2.11. So that we want only the ID and the salary. That is a this is the operation that is used. This is also one of the relational operation, that is I want only two columns, I want only two fields, I want only two data or two type of data that is available in a table. And we can also join the tables, that is also the part of the relational operations. There are multiple joins that is available. One is the form is a natural join, that is a tuple from the instructor relation that matches a tuple in the department relation. Then there is a Cartesian product that is also available that combines tuples from two relationships. If I want to find the Cartesian product operation, that is a Cartesian product rule that combines a tuple from two relations, but unlike the join operation, its result contains all pairs of tuple from the two relations, regardless of whether their attribute values matches or not. So what is the value, what is their value, what is the value, that is not the main point. That is the main point, and that is finding out or combines the tuples, combines the rows from the two tables. And there is also operation, there is also a, we can say the relational operation, that is a union. that performs as the union of the two, that is a similarly structured table, that is a table of all graduate student and the table of all undergraduate student. For example, one can obtain the set of all the students in a department. Other set operations such as intersection and the set difference can be performed as well. So there is a union, there is an intersection, there is a set difference. This is a result of selecting the attribute ID and the salary of instructors with salary greater than the 85,000. This is finding out that how much is a person that is used to find out whose salary is greater than 85,000. Only selecting the attribute, that is the ID and the salary. Now, this is the relational algebra. This is one of the important table that is used, that is a relational algebra. So this says the relational algebra defines a set of operations on the relations. So there is an algebra that is available, that is a relational algebra that defines a set of operations. That is, a set means a group of operations, that is multiple operations are performed on the tables. That is a set of, or defines a set of operations on the relations, paralleling the usual algebraic operations such as addition, subtraction, multiplication, which operates on number. So there is a relational algebra that defines a set of operations. There are multiple operations on the relations on the table that depends or that uses the algebraic operations, that is addition, subtraction, multiplication, which operates on the number. So there is a relational algebra under the relational operations in which we focus on the numbers and we perform various operations like addition, subtraction, multiplication. Just as the algebraic operations on number that takes one or more numbers as input and return a number as output, the relational algebra operations typically takes two or one or more relations as input and returns a relation as an output. So it combines two or more relations as an input and returns a relation as an output. That is, table is also considered as an input and table is also considered as an output. Relational algebra is covered in detail in chapter number 6. So there is a chapter number 6 in which all the relational algebra is covered in the detail. Then the next is the table that shows there are various relational algebra functions. There are various symbols that is used. So one of the table that shows there is a symbol and the example of the use. So what is the symbol? This is a symbol that is used for the selection. That is, it returns the rows of the input relation that satisfy the predicate. So if I want to select the multiple rows from the n number of rows, suppose there are 5 rows for example, and if I want to select only 2 rows, that is done by the selection. So there are two terms, one is the selection, one is the projection, and the selection is denoted by the we can say the selection is denoted by the sigma sign that returns are rows of the input that input relation that satisfy the predicate. Then there is a pi, that is a projection, that is a pi id salary, that is we can specify the output, that is we can specify the attributes. So selection is used for the rows and the projection is used for the columns. So output specified attributes from all the rows of the input relation that removes the duplicate results from the output, or removes the duplicate rows from the output. Then there is a natural join, that is join or that joins the two tables, two relations. For example, there are two tables, two relations, that is the instructor and the department, and that will be joined, that will be combined by using the natural join. Output pairs of rows from the two input relations that have the same value on relations that have the same name. So this is the instructor, this is the department. Then there is a Cartesian product, that is Cartesian product that output all pairs of rows from the two input relations regardless of whether or not they have the same value on common attribute. But natural join provides that have the same name and the same value between two relationships. Suppose we are taking two tables. So when we use the natural join, that joins the two tables by using the same values, by using the same name on the all the attributes on all the columns. But when we talk about the Cartesian product, that is a multiplication that provide all the rows, whether or not that may have the same values or the common attributes, that provides each and every product, each and every data, or combines each and every attribute of two tables. Then there is a union, that is a union means combination. So output the union of tuples from the two input relationship. That is, take two relationship, that is a pi and name instructor and the pi name student. That is fetching the attribute or fetching the specified attribute of the rows, that is the name and the name from the instructor and the name from the student. So there are two tables that is used, that is two tables are combined by using the union also. Union means combination. So one of the field, that is a name from the instructor, will be combined as well as the name from the student will be combined. In this example, we have performed the operations in either order, but that is not the case for all the situations. Similarly, or sometimes the result of a query contains duplicate tuples. That is, there are some scenarios in which the duplicate tuples, duplicate rows are available. Suppose if we select the department name attribute from the instructor relation, there are several cases of the duplication, including computer science, which shows up 3 times. So remember the table that we have studied, there is a department name, that is a computer science, that is available 3 times. Certain relational languages adhere strictly to the mathematical definition of a set and remove the duplicates. Others, in consideration of the relatively large amount of processing required to remove the duplicates from large result relations, retains the duplicate. So this is the saying that sometimes the duplicate values are also considered, are also taken place. So to remove them, there are multiple methods, like primary key will be used and the pure mathematical sense will be used. Of course, data in a database must be changed over time. A relational or the relation can be updated, that is, a table can be updated by inserting new tuples, deleting existing tuples, or modifying the tuples by changing the values of certain attributes. Entire relations, that is, the entire tables can be deleted and the new one can be created. This is also a provision that the entire table can be deleted or the entire table can be deleted and the new one can be created. We shall discuss through the relational queries and the update using the SQL in the chapter 3 to 5. Now there are chapters that is available, that is 3 to 5, that shows various relationship or that shows various relational algebra, that is focused on the relational algebra. So this is the topic that shows the relational operations. What are the various operations that is available in the relational model? And one of the main topic is the relational algebra, that contains the 5 types basically: the selection, then projection, then natural join, then set difference or the Cartesian product, and the union. So these are the 5 parts: selection, projection, a natural join, Cartesian product, and the union. So these are the 5 topics or the 5, we can say, the operation that is performed using the relational algebra. Now there will be a summary, that is a winding up of this chapter, that is chapter number 2. The first point says the relational data model is based on the collection of tables. When we combine multiple tables, that is known as a relational data model. The users of the user of the database system may query these tables, insert new tuples, delete tuples, and modify tuples. So relational data model is nothing but a collection of multiple tables. The different users can combine or may query the tables, may query or may insert the new tuples, delete the tuples, and update the tuples. There are several languages for expressing these operations. There are multiple languages that is used for expressing these tuples. Then the next point says the schema of a relation refers to a logical design, while an instance refers to the content at a point of time. So schema means the logical design, that is what is the overall design of a database, that is the logical design of a database. And the schema means that is, oh sorry, instant means database. Instant means at a point of time, what is the value, what are the different values, what are the different content that is available in the relation. The schema of a database and the instance of a database are similarly defined. The schema includes its attribute and optionally the types of the attributes and constraint on the relation. So schema also includes, the design also includes the attribute and the constraints such as the primary key, foreign key constraints. The superkey is a set of the one or more attributes whose values are currently to identify tuples in the table uniquely. So when we combine multiple attributes that is used to define, that is used to identify the tuple, that is known as the superkey. And the foreign key, that is a set of attributes in a referencing relation such that for each tuple in the referencing relation, the values of the foreign key attributes are guaranteed to occur as a primary key. Then next point says a schema diagram is a pictorial depiction of the schema of a database that shows the relations in the database. So schema diagram means a pictorial representation of the schema of a database, that is a pictorial representation of the overall design of the computer, overall design of the database that shows the relation in the table. That is, what is the relation in the table, or what type of relations are available in the table, and their attributes, the primary keys and the foreign keys. Then the next is the relational query language that defines a set of operations that is used by which users can find out the information from the or gather the information from the database. Then the relational algebra that provides a set of operations. So sorry. So there are multiple operations that is available. That is a relational algebra operation that provide a set of operations that takes one or more relations as an input and returns a relation as an output. Practice query languages such as SQL are based on the relational algebra. So SQL, that is a structured query language, are based on the relational algebra. And then these are the review terms, that is a table, relationship, and so on. And these are the various practice questions that is available. That is, what are the various questions that is available, that is, what are the various types that is available for the relational data model, that is, what are the various types of the relational data model, what is a primary key, what is a foreign key, what is a time slot relation. These are the various we can say the topics of the questions of the database design concept, that is chapter number 2, that is a relational data model. And this is one of the question that is available for the relational algebra, that is a selection, there is a projection. There are two parts. The pi is used for the selection, and there is a natural join also for combining the product or for combining the two tables, as well as there is a projection, that is to specify the various attributes, that is done by the projection, and the selection, that is used to selecting the various rows in the table. Then this is the exercise that shows how the relation will be maintained, or how the content will be maintained. Now comes to the chapter number 3, that is the introduction to the SQL, that is the structured query language. So this says there are a number of database query language in use either commercially or experimentally. So there are so many languages, there are so many database query languages that is available, that we can use either commercially or the experimentally. That is, either we can use in a commercial way, or either we can use in a experiment way, that is in a practical approach, either with the commercial way, that is a transaction of the goods and services. In this chapter, as well as in the chapter number 4 and 5, we study on the, or we focus on the language, that is the SQL. We focus on the widely used query language, that is the structured query language. So although we refer to the SQL language as a query language, it can do much more than just query a database. So as we said, it is a query language. I agree, but it is more than the query language. That is, it can do more than the query language. It can define the structure of the data, modify the data, and specify the security constraints. That is, it is not simply a query language that simply gives the output on the basis of query. No, but it also provides the structure, also define the structure, modify the data, and specify the security constraints. That is, specify the security or the integrity constraints. What are the integrity rules and regulations that is available in the database? It is not our intention to provide a complete user guides to present for the SQL, but we provide some fundamentals of the SQL, because this is some 2 or 3 chapters that is available for the SQL. So it's not very comfortable, it's not very easy to explain the SQL in whole 3 chapters, but we only give, or this book only gives the few chapters, few we can say the overview introduction to the SQL or some basics of the SQL, so that if you think about that you are going into the database concepts, you are going into the SQL concepts, you can go for it. You can opt for the SQL, you can read out the SQL, you can search the information from the SQL. But if your basics are clear, your concepts are clear, it's better to understand the high level concept, that is a MySQL that contains the programming language, then the SQL, that is a very good SQL that is available, that is how to create a table, delete a table, and alter a table and modify a table. So let's start with the next topic, that is the overview of the SQL query language. That is, what is the SQL query language? That is a structured query language. So IBM developed the original version of SQL, originally called as a SQL. So IBM introduced the original version of the SQL, that is known as the SQL. That is acts as a, or that acts as a part of the system R project in the early 1970s. The SQL language has evolved since then, and it has changed to the SQL, that is the structured query language. Many products now support the SQL language. SQL has already established itself as the standard relational database language. In 1986, the American National Standard Institute, that is the ANSI, and the International Organization for Standardization, that is the ISO. So in 1986, both the combination, that is the ANSI, that is American National Code for Information, or American National Standard Institute, that is the ANSI, and the International Organization for Standardization, that is the ISO, published an SQL standard that is known as the SQL 86. ANSI published an extended version for SQL 89 in 1989. The next version are SQL 92, SQL 999, 2003, 2006, and the recent is 2008. But this is the old version of the book. So now the recent is SQL 2010. The bibliographic notes provide reference to these standards. Now, now let's start with the basics of the SQL. That is, this is the theory of the SQL, that is started with the IBM, introduced with the IBM with the name SQL. Now the SQL language has several parts, that is it contains multiple parts. First is the DDL, that is the data definition language. So first part of the SQL language is the data definition language. So the SQL DDL provides commands for defining relationals or the relation schemas, deleting relations, and modifying the relations object or the relation schemas. So DDL, that is the data definition language, that provides the commands for defining the relations or the relation schemas, that provides the command how to define the, or what are the various schemas, that is what are the various relation schemas, deleting the relations, that is how to delete the tables, how to insert the table, how to provide the command for defining the relation schemas, and how to modify the relation schemas. So one is creating, that is defining, one is deleting, and one is modifying the relation schemas. So creating, defining, deleting, modifying, that is covered under the DDL, that is the data definition language. So a language that defines the data, that modifies the data, that does the data, that provides a command for defining, for modification, for deleting the data, that is covered under the DDL, that is the data definition language. In the same way, there is a DML, that is a data manipulation language, that is a DML. So the SQL DML provides the ability to query information from the database and to insert tuples into, deletes tuples from, and modify the tuples in the database. That is the next part, that is the DML. So what is the role of DML? That provides the ability to query the information from the database. That is how to get the information from the database by using the query, and how to insert the tuple, that is how to insert the rows, and how to delete the rows, and how to modify the tuple. So it works on the tuples, and the data definition language works on the table. So DDL, as a name advice, data definition language, that works on the tables, and DML, that works on the tuple, that works on the rows in the database. Then the next part is integrity. The SQL DDL includes commands for specifying the integrity constraint. So there is a constraint, there is a target, there is a restriction that is available, that is the integrity constraint. that shows how the what are the various commands that is available for the integrity constraint that the data stored in the database must satisfy. Updates that violates integrity constraints are disallowed. That is not allowed in the database. That is not allowed in the database concept. That is the integrity constraints, or that is a constraint on the integrity. Next, view definition, that is also a part of the SQL programming or the SQL language. The SQL DDL, that is a data definition language, also includes the command for defining the view. So DDL also includes the integrity constraints. The DDL also includes the different views of the database, that is what are the different views of the database. Then transaction control, that also includes the commands for specifying the beginning and the ending of transaction, that is a transaction control. So it defines the commands to specify the beginning and the ending of the transactions. Then next is embedded SQL and the dynamic SQL. That is, what is the difference between the embedded SQL and what is the difference between the dynamic SQL? So there are two types of SQL. One is the embedded SQL, one is the dynamic SQL. So embedded and the dynamic SQL defines how SQL statements can be embedded within a general purpose programming languages such as C, C++ and the Java. That is how to embed the various, or how to define the SQL statement that can be embedded with the general purpose programming. That is how to use the SQL, how to connect the SQL with the general purpose programming or the general purpose programming languages, that is the C, C++ and the Java. This is the next part. Then next is the authorization. That is the SQL DDL includes commands for specifying access rights to relations and views. That is, what are the various access rights to the relations, and what are the various access rights to the views. That is how to access the, or what are the various views, or what are the various access rights, that is the user can what are the user privileges, that what are the access rights that is available to the user. That is the authorization. That includes a command for specifying access right to the relations as well as the view. That is, what are the various we can say the security provision that is provided to the tables as well as the views of the table, or the view of the table. So these are the various parts, or these are the various parts of the SQL. So the SQL language has the various parts, and these are the various different parts of the SQL. One is the DDL, that is the data definition language. One is the DML, that is the data manipulation language. One is the integrity constraint. One is the view definition. One is the transaction control. One is the embedded SQL and the dynamic SQL. So DDL, DML, integrity, view definition, transaction control, embedded SQL and the dynamic SQL and the authorization. So these are the various parts of the SQL statement that is available, or various parts of the SQL programming. So in this chapter we present a survey on the basic DML and the DDL features of the SQL. That is a feature that is described as have been a part of the SQL standard since SQL 92. And these are the various chapter that provides a various coverage of the SQL language, that includes the various joins. Chapter number 5, more advanced features of the SQL language. Then that includes how to use the mechanism, how to get the data. Now let's start with the SQL data definition, that is the SQL DDL, that is the SQL data definition language. This says the set of relations in a database must be specified to the system by means of DDL. So whenever we say about the relations, when we say about the relations, that is the tables in the database, that must be specified to the system by means of DDL. So if I want to create any table, that must be defined, that must be created by using the DDL. So this says the set of relations in that database must be specified, must be used to the system by means of data definition language. The SQL DDL allows specification of not only a set of relations but also information about each relation. That is SQL DDL allows specification of not only set of relations but also provides the information about the relation. The first one is the schema for each relation, that is a SQL data definition language, or that is a means of the data definition language. So it is provide information about the relationship. First one is schema. So what does the DDL contains? What does the SQL DDL contains? The first one is the schema for each relation. That is data definition language of the SQL also includes the schema. That is what is the overall logical design of the relation, or what is the logical design of the table. Then the type of values that is associated with each attribute, that is what are the different values that is available with the attribute with the columns. Then integrity constraints, that is what are the integrity constraints, that is also covered in the DDL. And the set of indices to be maintained, or the set of values, set of variables to be maintained for each relation. So these are the different parts, these are the various information. One is a schema, one is a type of value, that is a data type. It is of char, it is of double, it is of int. Then integrity constraint, that is a constraint will be providing on the integrity. Then the set of indices, that is for each relation. Then security mechanism, and what are the security and the authorization information for each relation. That is if I am talking about one relation, that is a table, that is table student, what is the security, or what is the authorization method, authorization information that is available for the relation. Then physical storage structure of each relation on the disk, that is what is the physical storage structure that is available, or how the physically every relation is available on the disk, that is how physically the data will be stored on the disk. We discuss here basic schema definition and the basic types, that is what are the basic types and what are the basic schemas, that is what is the basic schema definition, that is a design definition that is available in the database. Then in the chapter number 4 and 5 we will discuss the other DDL features like indices, integrity constraints, physical storage structure. Then we discuss in the next chapter, in the next two chapter, that is chapter number 4 and 5. Now, next part is the basic types. That is, what are the various basic types that is available. Now, the SQL standard supports a variety of built-in types. That is, SQL standard contains a variety of built-in types that is available. That includes. So, what are the various types of the data that is available? And this is one of the important part. So, first part is the char. As we have studied in the C language, there is a char, that is a character, a fixed length character string with the user specified length n. So if I specify char 10, that is a char 10 means there are 10 characters in the value, there are 10 characters in the string, that is from 0 to 9. So a fixed length character string with user specified length n. The full form is character can be used instead. Then varchar, that is a variable length character with user specified maximum length n. The full form is character vary is equivalent. So this is also user specified, that is a char, but in vchar, that is a dynamic, that is a variable length with the user specified maximum length. That what is the maximum length of the character, what is the maximum length of the string, that is denoted by the varchar, and n is the number that is in the numeric, for example varchar 10. So there are maximum of the 10 integers, maximum of the 10 character that will be displayed, that will be stored in the string. Then next is the int, and that says an integer, that is a finite subset of the integer, that is a machine dependent. The full form of int is integer, that is equivalent. then small int, that is a small integer, then numeric, that is a fixed point number with the user specified precision, then real double precision, that is how to use the real and how to use the double precision, that is real values, that is we can say the float values, and real means the float value, that is the decimal values, as well as the double value that also contains a float value, decimal value, but with the higher capacity, that is a higher capability with the machine independent precision. Then float, there is also a float values with a precision of at least n digits, and the additional types are covered in chapter 4 topic 4.5. Now this says each type may include a special value that is known as the null value. So every type also contains a special value that is known as the null value. That is a null value that indicates an absent value that may exist but be unknown, or that may not exist at all. That is a null value that is not exist but may appear in the database. In certain cases, we wish to prohibit null values from being entered as we shall be shortly. And the char data type stores fixed length string, and the var character data type stores as an attribute that will be a, we can add the value, that is the maximum size is provided by the varchar. And when we compare a char type with the varchar, one may expect extra spaces to be added to the varchar type. So there will be extra space that is also available in the varchar type to make the length equal. So we can add the varchar, or we can add the characters to the varchar type. However, this may or may not be done depending upon the database system. So it depends on the database system, how it is used and how it is applicable on the database concepts. As a result, if the same value AVI is stored in the attributes A and B above, a comparison will take place, that is A equals to B. If it is stored, the same AVI is stored in the character or with the char data type, that gives the different result. If the same that is stored in the varchar, that gives a different result. So AVI in the first A and AVI in the second B, that is also stored in the, or that is also different in the B. We recommend you use the varchar type instead of the type to avoid these problems, because when we use the char, there are different values, because that is limited to the C language. When we use the programming, that is char is very much efficient, or very much comfortable, or very much compatible with the programming. But when we talk about the varchar, that is compatible with the character value. So this is the example that is given. For example, an attribute A of the type char 10. If we store the string AVI in this attribute, 7 spaces are appended to the string to make it to the 10 characters long. That is 7 characters are the blank to store the 3 characters, that is the AVI. But if we store in a varchar 10, that is if we use the varchar 10, and if we store AVI in the attribute B, no spaces will be added. Simply store the AVI, because in a char there is a 10 value, so that 7 blank spaces or the 7 blank characters will be used, or the 7 long characters or spaces are needed to use or store the AVI. But when we use the vchar, there is no free space, there is no spaces that is available, that is simply stores the AVI in the attribute B when we use the varchar. When comparing two values of the type char, if they are of different length, extra space are automatically added to the shorter one to make them the size before comparison. So it's better to use the varchar because it stores the value without the spaces. So it's better to use the varchar value. SQL also provides the nchar or nvarchar type to store multilingual data using the Unicode representation. So there is also a type that is known as the nvarchar type to store the multilingual data using the Unicode representation. Now next is basic schema definition. So we have talked about the basic types like real, double, float, char, varchar. Now next is what are the basic schema definitions, or what is the logical design of the database, how the database will be designed. That I'm going to start after the break. So let's take a break right now, then moves to this topic, that is the basic schema definition. So let's take a break right now. So come back from the break. Now let's start the session again. So next topic is the basic schema definition. That is, what is the basic schema definition? So we have finished right now about the data types or the basic types of the data. That is, what are the basic types that is available in the database, or what are the various types of the database that is available. Now next is the basic schema definition. That is, what are the basic schema definition, what are the various designing of the definition, or what are the various designing that is available in the database. That is the basic schema definition. So we define an SQL relation by using the create table command. That is, we create the relation, we create the table by using the command, that is a create table command. The following commands create a relation department in the database. So this is the command that is given, that is how to create the relation department or how to create the table department in the database. So there is a concept, or there is a syntax that is used. So this is the syntax, that is a create table department. So what is the name of the table? That is a department. That is a department name, that is of varchar 20, then building, that is of varchar 15, then budget, that is of numeric 12 and the 2, and the primary key is the department name. This is the syntax, how we can define or how we can create the table. So first of all, use the keyword, that is the create, and the table name is department, and these are the various columns, these are the various fields that is available in the department. There is a department name, that is of varchar type. There is a building, that is of varchar type. There is a budget, that is of numeric. There is a primary key, that is of department name. And the primary key is the department name. So what is the primary key? That is the department name. The relation that created has three attributes. What are the three attributes? That is the department name, which is a character string of maximum length 20. That the maximum character that is placed in the department name is the 20, which is a, and the building, that is a character string of maximum 15, and the building that is used, that is a maximum length of characters is the 15, and the budget, that is a number with 12 digits in total, two of which after the decimal place. That is, 12 digits are a total of the decimal place, or 12 digits are a total of the numbers digits that is used, and out of 12 there are two digits that is of decimal type also, so two of which after the decimal points. So there is a department name, that is a string, there is a building, that is a string, there is a budget, that is a numeric, with the 12 digits with the 2 as a decimal point. The create table command also specifies that the department name attribute is a primary key of the department relation. So this also specifies that what is the primary key? That is the department name. So general form of creating the table is this one. This is the general form. There is a create table R, then A1, D1, A2, D2 till AN, DN. So we can create the table with n number of integrity constraints, with n number of attributes, with n number of various types, that basic types, and there is a primary key that is also available. So this says where R is the name of the relation, R is the name of the table. So this is just like a syntax. A1 or AI, or each AI is the name of the attribute in the schema, that is AI is the name of the attribute that is available. DI is the domain of the attribute, or it specifies the type of the attribute like varchar, real, double, what is the type of the attribute, and AI along with the optional constraint that shows how to use the set of allowed values that is used for the AI. The semicolon shown as the at the end of the create table statement as well as the end of the SQL statement in this chapter is optional in many SQL implementation. This semicolon is not mandatory in this chapter, but it is very common to close the table or close the attribute that contains with or that is used with the semicolon. Now, SQL supports a number of integrity constraints. In this section, we discuss only a few of them. The first integrity constraint is primary key. That is a primary key, that is a A1, AI, AJ1, AJ2 till AJM. So the primary key specification says that attributes AJ1, AJ2, AJM forms the primary key for the relation. So when we talk about the primary key, that uniquely identifies the character, or that uniquely identifies the string, or that uniquely identifies the relation or the attribute. The primary key attributes are required to be non-null, that is the primary key cannot be null. We cannot specify the null values as a primary key. and that must be a unique. That the primary key is always a unique. That is, a no tuple can have a null key for the primary key, and no two tuples in the relation can be equal on all primary key attributes. That is, the no two rows have the same null values for the primary key, and the no two tuples in the relation can be equal primary key attribute. That is a very common, that is a unique for each and every row. Although the primary key specification is optional, but it is good, or it is generally a good idea to specify a primary key for each relation. So it's not mandatory to define the primary key in a table, but it is very good option to define the primary key so that your table is correct, your database is correct, your form is correct, and your primary key is correct. Then next is foreign key references. The foreign key specification says that the value of attributes for any tuple in the relation must correspond to the value of the primary key attribute of some tuple in the relation. So there is a primary key that says that the value of relation, that is, or value of the attribute that is available, must correspond to the value of the primary key that is available. There is a figure 3.1. This is a figure 3.1 that shows various table, various primary key as well as a various foreign key. And the next constraint is, one of the constraint is primary key, another constraint is foreign key, and the next constraint is not null. That is also a constraint. The not null constraint on an attribute specifies that the null value is not allowed for that attribute. So if I specify for attribute that is not null constraint, that means that attribute, that column does not contain the null value. That is a not null attribute or the not null constraint. In other words, the constraint that excludes the null value from the domain of that attribute. In the figure 3.1, this also explain, or the figure 3.1 also explain the not null constraint on the domain attribute of the instructor relation, ensure that the name of an instructor cannot be a null. That is, we cannot define the instructor, we cannot define the name of the instructor as a null. So the attribute that is used is a name, and the specification constraint that is used is the null. More details on the foreign key constraint as well as other integrity constraint that the create table command may include is available in section 4.4. This says SQL prevents any update to the database that violates an integrity constraint. For example, if a newly inserted or modified tuple in a relation has null value for any primary key, or if the tuple has the same value on a primary key in a relation, so SQL gives an error. So if there is not, if the same values can be duplicate value can be available, so SQL gives the error. SQL flags an error and prevents the update. Similarly, an insertion of a course tuple with the department name value that does not appear in the department would violate the foreign key concepts. Next paragraph says a newly created relation is empty initially. So whenever we create any relation, any table, that is empty at the initial level. We can use the insert command. We can use the insert command to load the data into the relation. That is how to load the data, or how to use the data into the relation. For example, if we wish to insert the fact that there is an instructor named Smith in the biology department with the instructor ID 10211 and a salary of $66,000, we write. So if I want to insert the fact that there is an instructor named Smith, so there is a name of the person instructor, that is a Smith, that is from the biology department with their ID, that is a 10211, and a salary of 66,000. So there is a concept that is the insert into instructor, that is the insert into the table instructor, that is insert into instructor. What are the values? There are different values, that is the instructor ID, that is the salary, name, and the department. So first is a instructor ID, that is a 10211, then there is a name, that is a Smith, then there is a department name, that is a biology, and there is a salary, that is a 66,000. Then so these are the various fields that is available. One is the instructor ID, then there is a name, then there is a department name, then there is a salary. So these are the four fields, these are the four column headings, or these are the four values that will be inserted. So insert into instructor, that is the first part. Then there is a value that is available, then instructor ID, then name, then department name, and the salary. The values are specified in the order in which the corresponding attributes are listed in the relation schema. That is, these are the value that is listed out, that contains various value that is listed out in a various value in a various attribute that are listed out in a relation schema. So the same pattern is follows, or the same order is follows, in which we can write the, or in which can create the table. The insert command has a number of useful features and is covered in more detail in section 3.9. Now we can use the delete command to delete the tuple from our relation. So if I want to insert any command or any tuple, any row, any record, then we use the insert into. And if we use the delete command, or if we use the delete command for deleting a tuple from a relation. So this is delete from student. That is delete from student. So this is a table, or this is the example that says this table will be created, that is the create table department. Then these are the various fields. The same example, the create table department, department name, building, budget, name, department name, building name, and the budget. Department name and the building is of varchar type, and the budget is of numeric type with 12 digits with the 2 decimal digits, and the primary key, that is the department name. Then again, next part is creating a table course. Okay, Nelda. Bye, Nelda. So shall I finish the class right now, or shall I continue the class of 5 minutes more? So this is the create table course. Then the next table is also created, that is of course, and these are the various fields. One is the course ID, that is of varchar type, that contains the 7 characters. Then title, that is also of the varchar, that contains the 50 characters. Then department name, that is of varchar, that is of 20 characters. Then credits, that is of numeric, that is what is the credit value that is available in the course, that is of numeric type, that contains the 2 digits with no decimal point. That's why it is saying, or it is displaying 0, that is there is no decimal point. Then the primary key, that is a course ID. So what is the primary key that is available? That is the course ID. Then what is the foreign key that is available? That is the department name, references, department. Next table is the instructor table. So one of the table is a department, next table is a course, and the next table is a instructor. That contains various fields. First of all, there is a ID, that is of varchar 5. Then there is a name, that is the name of the instructor, that is of varchar 20, that is not null, so it is not null value, that is a varchar 20. Then there is a department name, that is also of the varchar, that is a department name, that is also of the varchar, that contains the 20 characters. So this is the maximum limited 20 characters. Then there is a salary, that is also of numeric type. Then there is a numeric 82. So there are total 8 digits, and there are 2 decimal digits out of 8 digits. And then there is a primary key, that is the ID, and the foreign key that is the same, that is the department name and the references, and that means the department name is coming from the department table. Then create table section, that is the section is the name of the table, and these are the various fields, that is the course ID, varchar, section ID, varchar, semester, varchar, year, numeric, that contains 4 digits with no decimal point. Then building, varchar, then room number, varchar, then time slot ID, varchar, and the primary keys are these primary keys: so course ID, section ID, semester, year. And the foreign key is the course ID, reference is the course table. And the next table that is created is a table teaches. So that is the next table, that is a create table teaches. First of all, there is a ID, that is the ID of the teacher. Then that is a varchar 5. Then there is a course ID, that is a varchar 8, section ID, that is a varchar 8, semester, that is a varchar 6, and the year, that is a numeric that contains 4 digits with the no decimal point. And there is a primary key, this is the primary key, ID, course ID, section ID, semester, year. And there is a foreign key, that is a course ID, section ID, semester, year, and the reference table is section. And the foreign ID, that is ID, references, instructor. So there are two foreign ID that is used. So this is the SQL data definition for a part of the university database. So we have used the university database and we have made various tables for the SQL queries. So we can delete the command by using the delete command that deletes all the tuple from the student relation. So this is the delete command, that is delete from the student, that deletes all the tuples from the all the rows from the table student. Other forms of the delete also allow specific tuples to be deleted. That is, we can also use that there are different tuple, that is a tuple 1, tuple 2, that is also deleted by using the delete command. To remove a relation, so if I want to delete a whole table, that is a drop table will be used. So to remove a relation from a SQL database, we use the drop table command. The drop table command deletes all the information about the drop relation from the database. So there is a command that the drop table R is more drastic action than the delete from R. So we can use the drop table to remove the table to delete all the information about the drop relation. Right. So the later relation, that is R, deletes all the tuples in the R. And if I want to change, or if I want to modify or add attributes to the existing table, so if I want to add one more column to the existing table, that can be done by using the alter table command. So there is a command that is used, there is a alter table command. This is the alter table R add AD. So what is the table name? That is R that can be altered, and we can add the column name, that is the AD. So AD is the name of the column that is added. Right. So what is the syntax? That is the alter table name, then add, then the column name, where R is the name of the existing relation, A is the name of the attribute to be added, and D is the type of the added attribute. So A is the name of the column and D is the type of the column. We can drop the attributes from a relation by the commands. We can also drop the attributes. We can also delete the column from the table. That is the alter table R, then drop A, where R is the name of the existing relation, existing table, A is the name of the attribute that is deleted, and many database systems do not support dropping of the attributes, although they will allow an entire table to be dropped. So most of the databases, most of the concepts are not using the dropping the attribute, because when we drop the attribute, there will be a different concept, there will be a different scenario that is will use, because when we drop the any one column, then the whole table will be destroyed. So we cannot easily drop the value to drop the columns of the attributes, right? But we can drop the entire table. That is done by using the drop and then the table name. Now next is basic structure of queries like SQL queries. That is, what is the structure of SQL queries, or what are the basic structures of the SQL queries, that I'm going to start in the next class. So that's all for today's session. So uh, if there is any doubts, any queries, you can ask the doubts from me, and in the next class, that is in the tomorrow's class, I will be starting your next topic, that is the SQL queries. That is the basic structure of SQL queries, that is how we can write the SQL queries and what is the syntax that is used in the SQL queries. So that's all for today's session. Thank you so much everyone for listening me. In the next class, I will be taking a next topic, that is the SQL queries. Right. So that's all for today's session. Thank you so much everyone. Bye bye.